You ran the same coding job through Kimi K3 and MiniMax M3, and one bill came back 10 times higher than the other for nearly the same output. GLM 5.2 is sitting right in the middle, and nobody's talking about where it actually fits. These three open-weight models are chasing the same agentic coding jobs, but the cost and speed gaps are wild. Your pick decides whether your monthly bill is $42 or 10 times that. Test 1. Coding Benchmark Performance. The objection I keep hearing is that open-source models can't hang with the best closed models on real agentic tasks. SWE Bench Verified is the benchmark that actually tests that. Real GitHub issues, real pull requests, not toy problems. If a model scores below 80% here, your agent is going to be filing broken patches and costing you debugging time. I pulled the Val's AI independent leaderboard, and Kimi K3 came back at 93.4% on SWE Bench Verified, which is the highest open source score on that harness, and MiniMax M3 clocked in at around 80.5%, vendor reported. On Terminal Bench 2.1, the agentic task suite, Kimi K3 hit 80.9, and MiniMax M3 trailed at 66.0%. GLM 5.2 has no verified SWE bench figure yet, though it scores 81.0 on Terminal Bench from community testing. Kimi K3 takes test 1, and I didn't expect the gap to be this clean on an independent harness. That 13-point spread over MiniMax M3 is a real lead, not a rounding difference. That puts Kimi K3 up 1-0 with MiniMax M3 and GLM 5.2 still on the board. I've been running these models through real workflows long enough to know when a benchmark score actually translates to save time versus when it's just a number. Drop a comment below if a model's benchmark score has ever burned you on a real job. Test 2. Cost. The number that should stop you cold is the output token price. Run a moderately heavy agentic coding session. Say 100 million input tokens and 10 million output tokens in a month, and you're looking at a very different invoice depending on which model you picked. This is where raw performance numbers stop being the whole story. I ran the scale math. At 100 million input and 10 million output tokens a month, MiniMax M3 runs you about $42, and Kimi K3 charges 10 times that for the exact same volume. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. That's input at 0.30 versus 3 watt per million, and output at 1.20 versus 15 watt per million. GLM 5.2 has no pricing I could find, so it's sitting out this round entirely. MiniMax M3 takes test 2, and this is where the cost story gets wild. Input is 10 times cheaper, output is 12.5 times cheaper, and that 50% promo pricing is permanent, not a launch deal. That ties the overall score at 1 each, with GLM 5.2 still at 0. Test 3. Speed. A coding agent running at 40 tokens per second on a long refactor is going to make you feel every single second of that wait, and in an agentic loop with multiple calls, that latency stacks fast. Time to first token matters too, because a 3-second pause before every response breaks the flow of iterating on code. On Artificial Analysis's independent harness, MiniMax M3 hits 82.8 tokens per second, and Kimi K3 lands at 40.8, so MiniMax M3 is roughly twice as fast on the same test. Time to first token tells the same story, 1.65 seconds for MiniMax M3 versus 2.97 seconds for Kimi K3. GLM 5.2 has no speed data on any harness I could check. MiniMax M3 takes speed, and that throughput gap on an independent harness is the kind of difference you actually feel in a long agentic session. That moves MiniMax M3 ahead 2-1, with Kimi K3 holding 1, and GLM 5.2 still at 0. Okay, so we've got a real race now, but context and output limits are still ahead, and that's the dimension where the cost per task math can completely flip for long-form generation work. If you're doing big refactors or generating thousands of lines in a single response, the output ceiling test is the one you need to see before you decide. Test 4. Context and output limits. The failure mode here is specific. You're running a big refactor. The model hits its output ceiling mid-generation, and you get a truncated response with no warning, so now you're stitching together partial outputs and reprompting. At 512,000 tokens, that happens a lot sooner than at 1,048,576 tokens, and that difference is real for large codebases. Both models share a full 1 million token context window, so no difference there. On maximum output per response, Kimi K3 goes all the way to 1,048,576 tokens and MiniMax M3 caps at 524,288. That's double the ceiling for a single generation, which matters when you're pushing a model to rewrite a large file in one shot. GLM 5.2 has no published figure for either limit that I could find. Now, to be fair, most coding tasks don't actually need a million output tokens in one shot, and the default output limit is the same 131,072 for both models. But for the specific workload where you're generating a massive codebase or doing a full repo refactor in a single pass, that doubled ceiling is the deciding factor, and Kimi K3 wins it cleanly. Kimi K3 takes test 4 on the output ceiling, and I didn't expect that gap to be this clean in the official docs. 1,048,576 versus 524,088 is a hard limit, not a soft one. That ties the overall score at 2 each, with GLM 5.2 still at 0. Test 5. Deployment and modality. What actually breaks teams trying to self-host is this. You pick a model, start setting up your inference stack, and then find out you need 2 HGX B200 nodes just to get reasonable throughput, and your framework doesn't even officially support it. That's a multi-week infrastructure detour before you've written a single line of product code. I looked at the architecture numbers and the framework support lists. Kimi K3 is a 2.8 trillion parameter MOE with a 1.56 or a terabyte checkpoint in MXFP4, and it needs specific tensor parallel and pipeline parallel configs in VLLM 0.27.0 or later. MiniMax M3 is 428 billion parameters with about 23 billion active, and it has official support in SGLong, VLLM, transformers, K-transformers, and unsloth. That's 5 frameworks versus 1, right out of the box. Both models are genuinely multimodal, text, image, and video input, so on modality breadth, they're pretty much even. On everything else in this dimension, though, the gap isn't close. MiniMax M3's smaller active parameter count and broader framework support make it the practical choice for anyone who wants to run this themselves without a dedicated infra team. MiniMax M3 takes test 5, and that's the tiebreaker. 5 inference frameworks with official support versus Kimi K3's bespoke VLLM config is a real operational difference. MiniMax M3 wins the series 3-2 with GLM 5.2 at 0. Kimi K3 wins on raw coding ability, that 93.4% SWE bench verified score on Val's AI's independent harness is the highest open source number out there right now. It also doubles MiniMax M3's output ceiling at 1 million tokens per response, which matters for full repo refactors. And on BrowseComp, it scores 91.2% for agentic web navigation, beating MiniMax M3's 83.5%. MiniMax M3 wins on everything that drives your monthly bill. Input tokens are 10 times cheaper at 0.30 versus 3 core or oro. Output tokens are 12.5 times cheaper at 1.20 versus 15 oro per million, and that pricing is permanent. It's also roughly twice as fast at 82.8 tokens per second versus 40.8, and it's dramatically easier to self-host with a 428 billion parameter model and 5 supported frameworks. GLM 5.2 is the wildcard here. Its terminal bench 2.1 community score of 81.0 actually ties Kimi K3's 80.9 on agentic tasks, which is genuinely competitive. If you need a balanced middle option with strong agentic chops and you're not locked into a verified SWE bench number, GLM 5.2 is worth a look, though I couldn't find pricing or speed data yet. If your priority is cost per task efficiency, MiniMax M3 is the default pick, period. If you need the absolute best open source coder for complex agentic work, and a monthly bill 10 times higher than MiniMax M3's doesn't scare you, Kimi K3 is your model. GLM 5.2 sits in the middle for teams that want solid agentic scores without committing to either extreme, but I'd wait for pricing data before building on it. The one that'll get you, Kimi K3's custom MIT-style license includes a model-as-a-service clause that kicks in above $20 million in annual revenue. So if you're building a product on top of it and you scale, you'll need to renegotiate terms. MiniMax M3's community license has no equivalent revenue threshold buried in the fine print. Now, if you're wondering how Kimi K3 holds up against a closed model at the same price point, I ran that comparison too. Check out Kimi K3 versus Claude Opus 5 versus Grok 4.5, and you'll see whether that top open source SWE bench score survives when it's going up against the best closed source options available right now.